Gemma. It's nice and quick. I forget that. And voices off, please. Yeah, be quiet. Hush now, children. Something's going to work. I don't want to say shut up because that's rude, isn't it? Yeah. Oh, yeah, hand up. I should have tried the hand up, shouldn't I? Thank you. Okay, cool. This is a right-angled triangle. There you go. That's the grade 7 work out of the way. So when we're talking about trigonometry, we're talking about ratios, and I'll discuss the word ratio in a second, but let's just see how you go. This is the angle here, and typically we tend to use theta, but of course it could be any variable. But we tend to use theta for an angle, and then we label the sides of a right-angled triangle according to where that angle is positioned. So I always tell students, think about it like as if you're standing at that corner and you're looking out at the different sides. Well, first of all, regardless of where the angle is, this side is always called the same thing, and that is, the longest side of the triangle. I'll just put height for hypotenuse. The longest side of the triangle, it's also the side opposite the right angle. It's our old pal, the hypotenuse. Now, the other two sides are labelled based upon where the angle is, like I just said. So imagine you're facing there. You're either looking across here or you're looking next to here. So if it's all the way across the angle, what's that side called? Opposite. Yep. And then the other fancy word, who can remember it for the side that's missing it? Yeah. I'm just going to do ADJ for adjacent because I'm lazy. So, did I? Awkward, isn't it? Mitch has already started paying out on me. It's too early in the lesson, Mitch. Okay, you've got to pace yourself. Okay, so we've got hypotenuse, opposite, and adjacent. And remember, it's all based upon where that angle is. So if the angle is up here, this would be the opposite, and this would be the adjacent. So adjacent doesn't get used as a word that much these days, but adjacent does mean next to. So you can talk about your neighbours as being in the house adjacent to yours. It's the house next to yours. Hi, Liza. So is that okay so far? That's pretty clear, I hope. So trig is based upon a ratio of two sides. So a ratio is just when you divide one number by another, you get a number. That number is called the ratio. So we've got all sorts of combinations. We can talk about opposite over adjacent. We could also talk about adjacent over opposite, but we don't tend to in a standard trig course. We've got opposite over hypotenuse, and we've got adjacent over hypotenuse as the three standard ratios. And the reason why we call them ratios is because it turns out that we can create a triangle this big or this big, or maybe, can you see, that was actually not a little spot on the screen. Can you see that little triangle there? That little teeny tiny triangle as well. As long as that angle down there has the same angle as this angle here, then when I divide one of its little sides by one of its other little sides, I'll get the same number as if I divide this big old side with this big old side. And that's what makes trigonometry powerful, right? In that if it's the same, regardless of the size of the triangle, then I can then store all of those ratios in a table. And then if I've got a triangle with an unknown side length, I can use the ratio in order to work out that unknown side length if I know other facts. This is me doing your grade 9, 10 trig really briefly, just to remind you of the context. But that's the power behind it. Now, it used to be even before me, and yes, I did have calculators when I was at school. Even before me, they used to have things called trig tables or trig books, and then people would have to look up in the book to work out what the sine of 38 degrees is, and they would look it up in a book, and then they'd find what the value is. Okay, we've got all that tabular information is in a calculator, which is kind of handy, isn't it? Alrighty, so what does that mean? I'll keep it zoomed out now, and you can see we've got a couple of examples coming up. The ratios that we use are opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. And based upon those definitions, we use that particular notation, which should not come as a surprise to you. So S stands for, oh, did wrong colour. Wow, not enough people knew that. Not enough. Not people knew that. Can't get the right colour. Okay, so S stands for sign. Anyone who says sin is committing one, it is sign. Okay, we use a 3-letter abbreviation for each of these. Hence, we have SIN, COS, and TAN, but that is sign, and it stands for opposite over hypotenuse. So we've got sine of theta equals opposite over hypotenuse. Then we've got car, which is cos, what's the full one? Cosine, yeah. Cosine, which is, yep, adjacent over hypotenuse. So I'll write that down here. Cos of theta equals adjacent over hypotenuse. And then we've got TOA, which is tan. That's right. What's tan short for? Some say G. Cheers, yep. Oh, I've got it in caps. Tangent, abbreviated to tan, and it is opposite over adjacent. Okay, so tan of theta equals opposite, over adjacent. Right, again, this is all summary stuff, so review stuff. So does anyone have any questions over that? Okay, and you can see there I've got in my little box in the corner there, which I'll just zoom up just for a moment, then I'll zoom out again. That's how you basically solve a trig problem. And I'm not going to go through some basics. I'm going to go something a bit more depth to it. So number one, you look at where the angle is. You look at what you're trying to find out, and therefore you determine the ratio you want to use. In other words, are you going to use sine, are you going to use cosine, or are you going to use tangent? Number two, you substitute in. So you put in the values that you do know, and then number three, you solve it. Now I'm going to come up here because I'm going to show you how to do it on your GDC as well. So if you want to fire up your GDC while I'm getting organised here, please feel free to. If you want to follow on. But we'll have a look at these couple of examples. And I thought what I would do, because I'm going to assume that you're pretty much right on trig values, and if I gave you a basic triangle being able to work stuff out, instead what I'm going to do is I'm going to focus on the concept of elevation and depression. So on the bottom left corner there, I've got an elevation problem. And we can see, I mean, normally you'll be given a scenario rather than a picture. So it'll be something like Joe is in a boat and he's looking up at Victoria at the top of the cliff. And Joe, being a very well-equipped young lad, has his clinometer in his pocket. Clinometer is used to measure angle. And so when he looks up at Victoria, he notes that the angle is, it's a bit small, isn't it? Maybe a bit of zoom up, is 35 degrees. Now, with elevation, elevation is always taken from the horizon and then as you're looking up at something or someone. Okay, so elevation is taken from the horizon up towards an object like so. So there's the picture. We can see that the cliff is 200 metres high. So we know that Victoria is 200 metres high. And let me think. I've got to be careful not to make every single problem a tan problem. So I guess I'll do it this time. How far away is Joe from the cliff? So what we do is we put in the information that we need to find out. In this case, the distance from Joe to the cliff is going to be that blue line here, right? That's that. So let's label that with an X. And then we've got 200 metres here, from here to here. Okay, even though my distance is along here from Joe to the cliff, it's also the same from the bottom of the boat to the cliff as well, right? So I can use the 200 metres here because this will be the same distance here. Okay, so that's okay. That's probably not quite true, but anyway, it'll do. So what I tend to do, and you don't have to do this bit, particularly if the diagram's got plenty of time, plenty of room. But if you don't have room, I'd suggest that you then pull out the triangle, the right angle triangle that's created. Doesn't have to be proportional, and then put in the information you know. So, for example, I know I'll have to zoom up for this. I know that that angle there is 35 degrees. I know that opposite is 200, and I know that this one down here is x, my unknown. So then what I'm doing is I'm asking myself, what of the three ratios can I use with the information I've got? And the answer is tan. It's got to be tan, doesn't it? Because the other two use hypotenuse, which we don't have. So the only one left is tan. Do I have opposite? Yes, I do. Do I have adjacent? Yes, I do. Yep. Yeah. Yeah, 100%. What I was trying to fudge it then because you're right, Lockie, to pick it out. So what I should say, look, I'm going to just adjust the scenario to make it fit, but I could say that it's, the cliff is 200 metres, and so the cliff is 205 metres, and the height of the boat is 5 metres. Therefore, the distance from where Joe is to the top of the cliff is 200 metres, something like that. Yeah, you're absolutely right, and you'll see in the next example too. But I do take that into account with that diagram. Yeah, good point. Thanks, Lockie. I was trying to get past that. You kept me accountable. Okay, so the next thing we have to do is do the calculation. So if you remember from the first step, I said identify the ratio. Done, tan. Second thing is to write out that equation, putting in the stuff we know. So we know that tan of 35 degrees is equal to opposite. So again, we always look at it as if we're standing at that angle. So opposite is 200 and adjacent is x. We now rewrite the equation so x is the subject of the equation. I'm going to do it in one step. Tell me if it's confusing though, and I'll go through it properly. Basically, the x goes up here because I multiplied both sides by x, and the tan 35 goes down here because I divide both sides by tan 35. So practically, we're swapping these two positions over. And we can do it because it works when we're balancing an equation. So we've got x is equal to 200 over tan of 35 degrees. I'll pause there and just check if there's any questions. Okay, I just realised I haven't set up this video to work very well. So I might need to do the whole thing again. No, I might need to do this video in two parts. So I'm going to show you how to do on the GDC now. So I'm going to stop this video and then there'll be part 2 of this video in a second.